For a set of four distinct lines in a plane, there are n distinct points that lie on two or more of the lines. What is the sum of all possible values of n? And so let's just try it. Well, firstly, 0 less than or equal to n, which is less than or equal to 6. Because you can't have a negative number of intersections, and you can also have at most 4 choose 2 intersections, because you want the number of points that lie on 2 or more lines. And like each, so that means that you have at least, you have at most n is at most the number of pairs of lines, because each pair of lines only intersects once. So, and there's 4 choose 2 pairs. So yeah, we only have to check 0 through 6 and we see if it's possible to do it. So 0, we can pull that off. 4 parallel lines. It doesn't really matter though, because it doesn't contribute to the sum, but it's there for completeness. N equals 1. This one's pretty easy too. You just have them all intersect at one point and they won't intersect anywhere else. N equals 2 is tricky. So you should probably try to figure out if you can intersect it. So like, let's let these be our 2 intersection points. If those are our 2 intersection points, then, okay, I'm just gonna spoil it, I guess. You can't get lines to intersect. You can't get 4 lines to intersect at exactly 2 points. And then now I'll prove it. So there's at most 1 line which passes through both points. And also each of the 4 lines has to pass through at least one of these 2 points. Why is that? Well, if it doesn't pass through, if we have some line which doesn't pass through either of the points, then that means that if this line doesn't pass through any of the other points, doesn't pass through any of the intersection points, that means that this line never intersects anything. So that means that the other lines all have to be parallel to it in order not to intersect it. But then if A and B are like, so if C doesn't pass through the intersection points, then that means that A and B both have to be parallel to C, which means that A is parallel to B, which means that we have 0 intersection points. So each line has to pass through each line has to pass through at least 1. And then so let's draw this one. Let's draw that line, and then let's draw that line. So there's so there's 4 lines, and you end up having that you have to have 2 lines go through like the exact same set of points. Because there's only 3 choices. You can either go through both, go through one, or go 3 choices. You can go through both the left or the right one. So by pigeonhole, there's 2 lines which have the exact same setup. You can't have them both go through both because they have to be distinct lines. So you have to have something like this. But then these 2 lines here will end up intersecting. So there's at least 3 and you fail, unfortunately. Okay. N equals 3 is a bust. N equals 2 is a bust. Okay. N equals 3. You can do it like this, 3 parallel lines. N equals 4. This one's, you just do a 4-way like this. 5 is a bit tricky. I'm gonna draw 6 first, actually. So for 6, you just put them in something called general position. You just make it so none of them, there's no like repeats. And then this will give you 6 because like each pair of lines intersects exactly once. And now for 5, you might be suspicious now after proving that 2 doesn't have any. That's not possible to get 2. You might be suspicious that it's not possible to get 5 either. But and this is, yeah, to do that, like start thinking about like how do you get intersections and how do you decrease the number of intersections from 6. So one way is to make a 3-way, but making a 3-way decreases it by 2. Because instead of like 3 points, instead of having 3 intersections, you turn it into just 1 intersection. And so that's no good. But another way to get rid of an intersection is to make 2 lines parallel. So you just do that. And you get 5 intersection points. So 0, 1, 3, 4, 5, 6 are all doable. And so that's everything except for 2. Summing that up, you get D. I think this is quite hard for an AMC problem, especially proving that n equals 2. Oh yeah, just to reiterate, for the n equals 2 case, you have to have 2 lines. They cannot both, like the 2 left lines cannot both be parallel to the right one. So you have intersection.